It is given that f of x is equal to 0 is a transcendental equation with the sequence x0, x1, so on up to xn. Now, approximation which is given as xk plus 1 is equal to xk minus 1 f of k minus xk f of k minus 1 by f of k minus f of k minus 1, such that f of k into f of k minus 1 is less than 0. That means negative for all k, where f of k is nothing but f of xk. Now, he is asking this schema is known as what? Now, clearly it is nothing but false position method. That is option D. When the 3 students x, y and z write an examination, their chances of passing are 1 by 2, 1 by 3 and 1 by 4 respectively. Now we have to find the probability that at least 2 of them will pass. So probability of passing of x is given as 1 by 2. Probability of passing of y is given as 1 by 3. Whereas the probability of passing of z is given as 1 by 4. Now the probability that x will fail is 1 by 2 again. Probability that y will fail is 2 by 3 again. Probability that z will fail is again 3 by 4. Now is asking probability that at least 2 will pass. That means minimum 2, that is 2 will pass, probability of 2 passing plus probability of all the 3 passing. Now let us look into probability of 2 passing. So when it comes to 2 passing, it may be xy may pass or yz, or it may be zx. Now if it is all the 3, x, y, z. Now if x and y are passing, then z must fail. If y and z are passing, then x must fail. If z and x are passing, then y must fail. Now let us substitute the probabilities of all these values. That is 1 by 2 into 1 by 3 into 3 by 4 plus 1 by 3 into 1 by 4 into 1 by 2 plus z 1 by 4 into 1 by 2 into 2 by 3 plus 1 by 2 into 1 by 3 into 1 by 4. If we simplify, it will be 7 by 24. So the required answer is option D.
The question is, when the loop gain magnitude is very large with respect to unity, the overall gain of the feedback system shown in figure depends entirely on. See, if we look into the figure, it looks like a negative feedback system. For a negative feedback system, the closed loop gain is equals to open loop gain divided by 1 plus the loop gain, that is AB. See, if AB is larger than 1, then closed loop gain can be approximated as A by AB. That means it is 1 by B. Means the closed loop gain is going to be completely depends upon the feedback block, that is B. Hence option C is correct. Question is, in a series RLC circuit, setting R equals to 0 will produce. So if we look into the series RLC circuit, so if we make the R equals to 0, means it is kind of an LC network. There is a indefinite energy transfers between L and C, means it produces a sinusoidal oscillation. It is kind of an oscillator, hence it is an undamped response, because here R equals to 0 means zeta equals to 0, which is a damping coefficient. So we will get undamped response, that is option D is correct. Question is, the input to an envelope detector of a tone modulator signal is given as V of t, the maximum value of the time constant of a detector, so that it can always follow the message envelope is. We know that in case of an amplitude modulation, the output waveform before it is giving to the envelope detector is going to be like this. Means this is in an envelope, means that is a time domain modulating signal. So the carrier is modulated carrier is inside of the envelope. So in order to detect the message, we need to detect, because the information is present only in the envelope of the signal. So the time constant should be, that is RC should be greater than 1 by FC, and it should be less than 1 by FM. But there should be an exact value, means the maximum value of RC should not exceed this, RC should be less than 1 by omega n 1 minus m square divided by m, which is the limit on time constant in case of an envelope data in order to avoid the diagonal clipping. That is, option C is correct. Question is, which one of the following statements is true? When a frequency modulated signal is produced when a modulating signal is integrated and applied to a PM modulator. Yes, it is a correct statement. And for statement B, for sinusoidally modulated FM carrier, it is possible that for a particular values of modulation index, the power lies in the side frequency and there is no power in the carrier at all. Okay, this is also true statement because at certain values of beta, the Bessel function is going to be a 0 at carrier functions. Similarly, statement D is also correct because PM signal is produced when a modulating signal is differentiated and applied to a frequency modulator. The wrong statement is only C, hence option C is correct. For the signal x of n shown in the figure, the x of n is equal to 0 for n less than minus 3 and n greater than 7. If x of omega is the Fourier transform of x of n, then which one of the following is true? See, the given sequence is x of n. So if we advance this sequence by 2 units, that means x1 of n is equals to x of n plus 2. So if we apply the Fourier transform to this equation, then we will get that is x1 of e power j omega, which is related to the x of omega as j2 omega x of omega. So x of e power j omega is nothing but e power minus j2 omega and x1 of e power j omega. So the angle of x of e power j omega is nothing but minus 2 omega. Here x1 of e power j omega is nothing but a real function whose phase is nothing but 0. That is, angle of x1 of e power j omega is 0 degrees. So here x of e power j omega is nothing but summation x of n e power minus j omega n. From this, x of 0 means omega equals to 0 is equals to summation of x of n, which is not equals to 5, hence option A is not true. Here x of n 1 by 2 pi minus 2 pi to pi x of e power j omega plus j omega n d omega. Here x of 0 is nothing but 2, it is going to be 4 pi, hence option B is also not true. Hence option C is the only correct option from the given explanation, hence C is the correct option. Here the question is, for the LTI system described by the second order differential equation having 0 initial conditions, the transfer function is. We know that the transfer function which we are deriving from the by using Laplace transform, that works only under 0 initial condition. So we can apply the Laplace transform in order to get the transfer function here. If we apply the Laplace transform to the above second order differential equation, we will get 2s square 3s plus 4, this is y of s, equals to, that is r of s 1 plus 2e power minus s, because here the ramp function is delayed by 1 unit, hence it is multiplied by e power minus s. So y of s by r of s is nothing but a transfer function under 0 initial conditions divided by 2s square plus 3s plus 4. Hence option C is correct.